In this section, we learn how to graph nonlinear inequalities. We looked at linear inequalities already. The process is very similar. Again, remember the dotted boundaries represent situations where there's inequalities without equals, solid boundaries when there isn't equals. So this first example on the left represents something that does not have equality, but on the right there is equality. The shaded region represents an answer. If I want to figure out what this inequality is, I can choose a test point like 0, 1, which is in the region. I know the equality is y equals x squared, so I substitute 1 in for y, 0 in for x, and I see that 1 is greater than x squared. So this inequality is y greater than x squared without the equals because of the dots. The second one, the boundary is represented by, let's see, x plus 2 all squared minus 1 representing the vertex movement, and the a value is 1/2, as you can see the compression that's there. Now, if I substitute a point in like 0, 0, I would be comparing 1/2 of 2 squared minus 1 with 0. That's 2 minus 1 or 1. 0 is less than. And because I chose a point that's in the region, this is the correct inequality, so I will use it along with an equal sign because of the solid boundary. And I'll write 1/2 bracket x plus 2 all squared minus 1, and that represents that shaded region. Okay, a couple of examples for you to try. You may want to pause, give it a try, and then see if you get the same answer. Okay, assuming you've given this a try, first of all, I see negative 1, because I go down 1, right 1. I have a movement to the left by 1, and I have a movement up by 2. That's the equality. I see that 0, 0 is in the region, so I'll substitute 0 in here. 1 squared is 1, minus 1 plus 2. 0 is less than 1, and this needs to be the inequality that I use. So I'll write less than negative brackets x plus 1 all squared plus 2, no equals because it's a dotted line. Alright, here's one that's a little bit harder. You may want to pause and try this one out. This is a system. This is two nonlinear graphs together. Okay, assuming you've given it a try, let's go through it. The first one is an a value of negative 1. It has no left or right movement, and it's up 2 units. Okay, 0, 0 is a test value that I can use that's in the region, so I'll be comparing 0 with 2, and 0 is less than. It's solid, so I'll write y less than equal negative x squared plus 2. That represents the green parabola opening down. The second one, the second one, part B, is a parabola opening up, so it's positive x plus 1 all squared and 3 units down. 0, 0 again is in the region, so I will substitute that, and I will be comparing 0 with negative 2. 0 is greater than. And that's the correct inequality because the test point is in the right region. So I'll be writing greater than as well as equals due to the solid boundary. X plus 1 all squared minus 3. These two taken together represent the equations for that region. Now, something somewhat different. Solving quadratic inequalities. Sometimes you will get a representation with only x and an inequality you have to solve. What you do is, first of all, consider it as an equation. Solve the equation using factoring, completing the square, or quadratic formula. Next, use your solutions to divide a number line into regions. If you have one solution, you would have 2 regions. 2 solutions would provide 3 regions. Take a test point from each region and see if those test points are true or false in your inequality that you started with. If you find a true test point, that's revealing that the region is a solution. Now let's work through some examples because that sounds a bit confusing. So here we have x squared minus 2x minus 3. I'm going to consider x squared minus 2x minus 3 equals 0. Consider the equality. This one factors. I chose an easy one to start with. The zeros, or x-intercepts, are 3 or negative 1. So I'm going to use these on the number line of x to represent the places where I form regions, region A, B, and C. 2 values to the equality leads to 3 regions. I'm going to choose a test point in each region. Something convenient. Negative 2, 0, and 4. I'll choose whole numbers as small as possible. Now I'm going to test these values in the inequality and see what happens. So let's go right up to the first line. Negative 2 all squared minus 2 times negative 2 take away 3. Is that greater than or equal to 0? It is not. See, this would be 4 plus 4 minus 3, which is 5, and I just made a mistake. It is true, actually, not false. So I found the right region. A is a solution. I keep going like that with B and with C. Let's check out 0. 0 squared minus 2 times 0 minus 3. That's 0 minus 0 minus 3. Negative 3 is not greater than or equal to 0. That's false, and that is not a region. Lastly, let's test 4. 4 squared minus 2 times 4. Subtract 3. That's going to be 16 minus 8 minus 3, which is 5. And again, yes, that is greater than 0, so that's true. So region A and C are solutions as regions. So my answers then are from negative infinity all the way up to negative 1, and from 3 all the way to infinity. Now looking back, notice that I had an equality. It wasn't inequality, but there was also an equals there. So those x-intercepts are solutions, so I need a square bracket, meaning they're included. Okay, over to the right, same idea. This one's a little bit trickier because it's not going to factor. So I'm going to need to use quadratic formula. Maybe pause and try this one out. Try to follow the model on the left side and see how you do. Okay, assuming you've given that a try, we've got negative 2 squared minus 4 times A times C. That's all in the radical, and it's over to A, where A is 1. So I have 4 plus 8, which is 12. 12 is 2 root 3. I've got some common factors of 2, so I can rewrite this as 1 plus or minus root 3. Okay, now root 3 is about 1.7. So 1 plus root 3 is about 2.7. So a test value to the right of that could be 3. 1 minus root 3 is about negative 0.7. So I could test negative 1, and I could test 0. Alright, going back to the original inequality, I have negative 1 squared minus 2 times negative 1 comparing to 2 times negative 1. So 1 plus 2 greater than negative 2. That's true. So let me just put some letters to these. A is a solution, region A. Let's test B. Is 0 squared minus 2 greater than 2 times 0? Negative 2 greater than 0. That's false. So not region B. Region C, I'm going to have 3 squared minus 2 times 3. I'm comparing it to 2 times 3. So 9 minus 6, or 3, compared with 6. Is 3 greater than 6? No. Just make sure I didn't make a mistake there. Minus 2, I did make a mistake there. I don't want that there. That's just the number 2. So this is 9 minus 2, or 7, comparing to 6. So yes, it is. C is a solution. So A and C are solutions. So I can form my answer as values from negative infinity to 1 minus root 3 inclusive, or 1 plus root 3 all the way to infinity. That's the basics of how to work with inequalities that are not linear.